Okay, Assalamualaikum and good day to all my students. So this is our final video for the MEC281. Uh, this is also the final part 3 of the chapter 4. So in the previous video, we have learned about polymer, and for this video, we are going to learn about the composite. Okay. Wait a second first. Okay, where is our first slide of composite? Okay. Okay, so this is the first slide of 4.3 composite material. Types, properties, and applications are the knowledge that we are going to learn about the composite materials. In this video, at the end of this video, you should be able to explain the components of composite, understand the classification of composite materials, and also you should able to explain the differences among the various type of composite matrix, short form of PMC, MMC, and CMC. So at the end of this video, at least you should be able to comply all these outcomes. Okay, so let's go to the basics of composites. The definition of composites is the material that consists of two or more physically and or chemically distinct, suitably arranged or distributed faces with an interface separating them. Composite multi-phase material, metal alloy, ceramics, and polymer, artificially made. And the composite also has characteristics that are not represented by any of the components in isolation. Materials have specific and unusual properties in aerospace, underwater, bioengineering, transportation, and industries, and so on lah. So, ayat mudahnya dia adalah combination dua atau lebih secara fizikal atau secara chemical yang disusun melalui interface yang berbeza. Maksudnya satu lapis, layer lain-lain. Okay, so beza antara setiap material tu bila combine, so dia akan kita panggil dia composite. Okay, dengan syarat dia lebih daripada satu lah, dua ataupun lebih. Okay, contohnya kita boleh combine metal, ceramics and polymer, ataupun metal dengan ceramics, ataupun ceramic dengan polymer, ataupun semua sekali. Okay, so that will form a composite material. Okay, so this is what we call the interface, and this is the matrix. Matrix is like a big column, okay, a big domain of the composite materials. So dalam ni dispersed faces reinforcement. Okay, dalam bentuk macam ni awak baca composite composed of two faces. One is matrix, continuous and surround the other faces, and two is dispersed faces, shape of particle size, distribution and orientation. So you should know and how to differentiate between which one is the matrix and which one is the dispersed faces. Okay, so this is the dispersed faces and this is the matrix. Okay, matrix, a bulk phase which is continuous surround the reinforcement, provide uniform load distribution to the reinforcing constituent. General polymer and metal ductility is desirable. Okay, ceramic matrix to improve fracture toughness. Example of metal, polymer, and ceramic matrix. So Matrix is like uh, the house, the main physical things, okay, yang maksudnya disperse dalam tu lah, disperse faces dalam tu, dia yang akan mengelilingi reinforcement yang ni lah, disperse ni, okay, disperse faces ni ataupun kita panggil juga reinforcement. Okay, ni kita nak faham macam mana composite tu lah. Matrix ni yang mengelilingi dia. So yang ni yang betul-betul yang dapat shape of particles, particle size, distribution and orientation. Okay, dalam bentuk partikel lah ni, dalam case particle. Okay. So purpose of matrix, it binds the fibers together and acts as the medium by which an externally applied stress is transmitted and distributed to the fibers. Only a very small proportion of an applied load is sustained by the matrix phase. Furthermore, the matrix material should be ductile. In addition, the elastic modulus of the fiber should be much higher than that of the matrix. So the matrix act like a protector for the fabrics, for the fibers in the composite. Macam itulah lebih kurang. Dia kena ductile, tapi dia akan kuranglah strength of modulus, elastic modulus. Dia akan kurang strength, tapi dia tinggi elastic modulus compared to fiber. Fiber ni yang contohnya kita combine besi dengan getah contoh. Okay, so besi cara kita letak dia tu kita guna fiber. So yang getah pun fiber. So apa maksud dia? Matrix tu yang tolong protect tu lah. Okay. Ni terlalu banyak teks. Kalau saya baca satu-satu pun macam bazir masa. So I will leave it to you to read by your own. So we go faster lah in this video. And purpose of matrix, the matrix separates the fibers, and by virtue of its relative softness and plasticity, prevents the propagation of brittle cracks from fiber to fiber, which could result in catastrophic failure. In other words, the matrix phase serves as a barrier to crack propagation. Ni maksudnya saya tadi cakap dia adalah protector. Dia matrix phase ni akan mengelakkan daripada berlakunya crack lah, retak. Okay, even though some of the individual fiber phase, total composite fracture will not occur until large numbers of adjacent fiber, once heavy fail, form a cluster of critical size. Sebab fiber ni banyak dalam tu, fiber ni kan halus kan. So kalau satu fiber je putus ke pecah ke tak ada masalah. Tapi kalau matrix ni dia satu besar terus. So matrix ni tak boleh rosak lah, kata dia akan terus rosak. Okay, dispersed phase geometry in this context means the shape of the particles and the particle size, distribution and orientation. Okay, tengok ni dispersed phase, ni matrix. Matrix ni yang sebesar-besar ni lah, yang protect dia, barrier dia. Okay, ni kalau banyak fiber, lagi kecil fiber, lagi ni, ni fiber dalam bentuk petak. So ni orientation dia berbeza. So fiber boleh duduk dalam bentuk orientation yang berbeza-beza lah. Okay. Yang dalam ni kita panggil dia apa tadi? Reinforcement or dispersed phase. Okay, apa pula dispersed phase? Fiber reinforcement are classified as follows. Okay, fiber reinforcement or fiber dispersed phases. Okay, fibers, normally polymer or ceramic, amorphous or polycrystalline, glass, carbon, boron, aluminium oxide, and so on. Viscous, thin single crystal that have very small diameters, example of graphite, SiC, and so on. Wires, metal alloys that have relatively large diameter. Okay, so the fiber reinforcement will provide superior level of strength and stiffness to the composite. Okay, provide thermal and electrical conductivity, control thermal expansion, and wear resistance in addition to the structural properties. Okay, so composite ni dia combine beberapa material yang kita cerita tadi, sama ada ceramics, alloy, metal, and so on. Jadi untuk dapatkan properties yang sangat diperlukan dalam setengah application lah contohnya. So bila kita nak dia sangat kuat macam Kevlar, okay, Kevlar baju garis peluru kan. So kita perlukan level strength yang sangat tinggi lah. Jadi tu yang composite dihasilkan lah. So important characteristic for reinforcement. Okay, these are the factors for the reinforcement phase. One is the diameter size, a high aspect ratio, high degree of flexibility. Okay, so all of these are the important characteristics for reinforcement phase in the composite. Okay, apa pula interface ni? Okay, interface tadi kita tengok balik kat sini. Okay, interface yang warna kuning kan, matrix yang tolong pegang ni, rumah dia, matrix sebagai rumah. So yang ni dispersed reinforcement, yang kuning ni, ini adalah interface. Apa interface? So kita tengok apa benda interface yang dia cerita kat sini. Interface can be defined as a bounding surface where a discontinuity of some kind occurs between matrix and reinforcement. Okay, dia macam penutup lah, pelindung on tengah, okay, material tengah between matrix and dispersed phase. So ada interface di antara sebelum dispersed phase jumpa dengan matrix dalam ni. Sebab apa dia perlukan tadi? Sebab apa interface dia perlukan? Okay, sebab dia kata where a discontinuity of some kind occurs. Okay, kalau apa-apa yang tak cantik ngam dia, tak bercantum cantik antara matrix dengan reinforcement, so tu tugas interface sebagai orang tengah. Interface is an essentially two-dimensional region through which material parameters such as concentration of an element, crystal structure, atomic registry, elastic modulus, density, and coefficient of thermal expansion change from one side to another. Okay, dia parameter dia boleh berlaku berbeza-beza dari segi nilai-nilai ni lah, antara concentration of element, crystal structure, and so on yang dah diberikan sini. Okay, so kita masuk ke classification of composite material. Jadi composite tadi yang kita cerita ada 3 jenis. Ni general. One is particle reinforced, fiber reinforced, and structural. Ini cara lain-lain dari segi jenis-jenis composite. Okay, lepas tu pecahan dia pula. Particle reinforced pecah kepada large particle, dispersion, strengthen. And for the fiber reinforced, it has another category, continuous and discontinuous. Okay, and then for the structural also has 2 category, laminates and sandwich panel. Okay, awak tengok nilai lain. Berbeza dari segi method, berbeza dari segi material yang dia dapat nanti, properties yang dia dapat. Okay, dispersed phase of particle reinforced sini. Composite is equal as particle dimension are the same in all direction. Okay, detail dia sampai tahap particle dimension dia sama dalam semua direction. So dia macam sama rata lah dan untuk segi particle dia. Okay, yang gambar rajah ni pula tunjuk fiber reinforced. Contoh ni yang besar ni. Okay, the dispersed phases has the geometry of a fiber, large length to diameter ratio. Okay, yang mana sekarang ni dispersed phases? Yang ni kan, yang macam silinder ni. Okay. Okay, Untuk yang short discontinuous, short fibers dia bentuk macam ni. Ni randomly oriented. Okay, untuk laminate, awak tengok ni, laminate macam kita laminate kertas lah, dilapik-lapik-lapik. Okay, sandwich panel pula, kita macam kita, nama lagi sandwich, macam kita buat sandwich. Dia bukannya macam ni kan, dia layer by layer by layer. Ni macam kek lapis, macam laminate kertas. Yang ni sandwich panel ni macam kita punya roti sandwich. Atas roti, bawah roti, tapi tengah tu ada inti, tuna ke apa. So bentuk dia, dalam segi dia ada line sikit lah, compare dengan laminate. Okay, so patah balik tadi berapa jenis komposit ada? 3. Yang besar dia particle reinforced, fiber reinforced, and structural. Okay, boring kan? Sebab tu lah awak kena baca sendiri. Baca sendiri, kalau tak faham awak tengok YouTube, awak tengok dalam buku. Okay, tengok nota balik. Sebab dari segi nota ni saja susah nak faham lah. Kita kena masuk dalam, kita kena baca detail. Tapi sebelum tu kena minat. Minat apa? Minat kena study. Selagi awak tak study, tak boleh jawab lah soalan nanti. Okay, so slide ni one by one akan explain satu-satu jenis. So saya akan tinggalkan untuk awak nanti untuk baca ni. Sebab kalau ikut kan ramai lecturer akan suruh student baca sendiri yang chapter 4 dari segi composite ni. Sebab dia terlalu fakta kan, awak kena baca. Okay, ini jenis-jenis particle reinforced composite, jenis-jenis dia. Particulate, flake, and filler. Okay. Ini contoh konkrit yang kan konkrit pun salah satu komposit sebab dia campur aggregate, dia campur simen, dia campur pasir. Okay. Okay. So pendekkan video, awak baca ni banyak ni. Ni structural composite yang saya cerita tadi, sandwich panel dia bentuk macam ni. Okay, ni laminate dia. Plywood pun salah satu composite juga. So dari segi jenis composite pun awak boleh tengok bila application dia. Macam yang berlapik-lapik layer by layer ni, kita boleh assume ni adalah laminate composite, structural composite lah, under structural composite. Okay, kalau yang ada macam-macam ni adalah sandwich. Okay, dia bawah structural composite juga. Okay, macam sailboat ni, papan luncur awak ni pun adalah composite. Tengok banyak atas lapis, dalam pula sandwich, macam-macam lah. Okay, so summary dia, method of reinforcing plastic ada 3 tadi. Particle reinforce, lagi yang kedua apa? Ingat tak? Yang kedua fiber reinforce, dan yang ketiga structural composite. Okay, ini structural, ni fiber reinforce, yang ni particle. Okay, so kita rehat sekejap 5 minit. Okay, let's get continue. So before the break, we have learned about the 3 types of composite. The first one is particle, and then fibers reinforce, and then the third one is structural composite. Okay, so the composite also has 3 categories of polymerometric composite Pmc. This one is polymer. Based on that matrix, it has another 2 types, ceramic and metal. So for the ceramic, we call it Cmc, and for the metal, we call it Mmc. So we have 3 types: Pmc, polymer matrix composite; ceramic matrix composite, Cmc; and also metal matrix composite, Mmc. So the main difference between 3 types of PMC, CMC, and MC is the material of the matrix that is used to form the composite material. Okay, so let's get learn about the polymerometric composite PMC. Okay, PMC consists of a polymer resin as the matrix with fibers as the reinforcement medium. So the matrix that is being used in PMC for sure is the polymer. So and then for the fiber, it use another medium that it should be from the reinforcement medium. Should be comes from glass, carbon, and aramid fibers, and so on lah. Okay, polymer matrix mostly used in polyester and vinyl ester. This is an example lah. Okay, so epoxies, PMCs for aerospace application, better mechanical properties and resistant to moisture than polyester and vinyl ester. It also can be used using polyamide resin for high temperature application, and for the aerospace application, the matrix also come from the polyether ketone, polyphenylphthalein sulfide, and polyethylamide. Okay, and so on lah. So all of that matrix must come from the polymer material. So if not, it cannot be called as PMC. Okay, so the exercise, you should summarize the article in the textbooks. And example of PMC is glass fiber reinforced polymer, GFRP. Fiberglass consists of glass fiber, blah blah blah. Okay, you can read by your own. Okay, the application of fiberglass we can see here in the plastic pipeline, tanks, air tangki rumah awak tu, tangki fiberglass, plastic pipeline yang plastik pun ada yang guna fiberglass, ataupun boat, vessel for chemical process industries and so on. Okay, so itu adalah salah satu jenis of polymerometric composite, and then we call it glass fiber because of reinforced face is using the glass fiber. Okay, and if we use the carbon fiber for the PMC, we combine with the polymer, and we have CFRP. We call it carbon fiber reinforced polymer composite. Okay, this is widely used in sport and recreational equipment and so on. Okay, so most of the material are found in our daily life also come from the PMC, polymerometric composite. Okay, and we now go to the cross section of fiber reinforced material. Okay, this is the matrix, the Kevlar fibers and graphite fibers. So in this case, it use two type of fibers, Kevlar and graphite, and one type of matrix. So if it is PMC, for sure the matrix must come from the polymer material. Okay, this diagram is another example of PMC that is used in the aircraft. Okay, here the blue parts is using carbon fiber, and the green part is aramid, and the red part use the glass fiber. Okay, advantages of PMC, found widespread application, can be easily fabricated into any large complex shape, do not involve high pressure and temperature, and equipment required may be simpler. Okay, so the advantages of PMC, these advantages: low maximum working temperature, high coefficient of thermal expansion, and hence dimensionally instability. So it can change form in certain situation, and sensitivity to radiation. The absorption of water from the environment may have many harmful effects, which degrade mechanical performance, including swelling. Okay, and also formation of internal stress and lowering of the glass transition temperature. Okay, so these are the disadvantages of PMC. Okay, and now, and these are the properties, main properties of PMC. Okay, you should do your own notes to memorize all these things. If you cannot memorize, it's okay. Just make sure you know where to find the information of the properties when the situation needs you to have to use the properties information of PMC, let's say in the final exam or in the quiz. Okay, and then now we go to the MMC, metal matrix composite. Okay, so for sure the matrix used in the MMC is coming from the metal material. Okay, the matrix is a ductile metal. Okay, if not metal, it cannot be called MMC, right? Okay, so the most common metal employed in MMC are aluminum, copper, titanium, and magnesium. All of these materials are common metal that are being used in forming the MMC. Okay, typical fiber used in the composite system are carbon and silicon carbide. Also, the carbon and silicon carbide can be combined with the metal to get the metal matrix composite here. Okay, so the reinforcement may improve stiffness, SB strength, and abrasion resistance, creep resistance, thermal conductivity, dimensional stability, and the particulate of fibers also can be from the continuous and discontinuous type, viscous, and so on. Okay, so right now we have the advantages and disadvantages of MMC. Okay, compared to the PMC, polymer matrix composite, MMC has advantages of non-flammability. So tak terbakar lah. So great resistance to degradation by organic fluids. Dia tak deteriorate, rosak kalau terkena sangat terkena organic fluid. Okay, and surface temperature higher than PMC and resist wear and thermal distortion. Okay, these advantages dia dia lagi mahal, kan? Dan penggunaan dia sangat limited lah. Use resisted. Okay, so example of MMC we can find in the automotive, aluminium oxide or carbon fiber. And pernah dengar kan selalu carbon fiber kan? Kita guna dalam kereta-kereta yang supercar, hypercar tu sebab nak gantikan aluminium ataupun besi, sebab carbon fiber lagi ringan, lagi kuat. But for sure dia lagi mahal lah. These are the parts in the automotive that use the MMC, drive shaft, stabilizer bar, suspension and transition component, and so on. And for the aerospace, we have boron fiber for space shuttle, orbital, and continuous graphite fiber for the Hubble Space Telescope. Hubble ni dah rosak sekarang kan? Kalau tak tahu lagi, cuba check. Hubble dah di retired, dah di apa panggil? Dah diberhentikan fungsi dia lah. Okay. So these are the table that shows material of fiber and matrix and the applications for that composite. Let's say we combine the graphite as a fiber and aluminum as the matrix. The application is used in the satellite, missile, and helicopter structures, and so on. Okay, so these things you should not memorize lah, but you have to know the common combination of fiber and matrix that can form the metal matrix composite MMC. Okay, still the advantages and now the slide of ceramic matrix composite. So this is the last one. Okay, we have three types as I said just now. The first one is polymer, second one is metal, and the final one is the ceramic. So ceramic matrix composite, short form CMC, contain a ceramic matrix such as alumina and calcium aluminosilicate reinforced by fibers such as carbon and silicon carbide. Okay, fibers, most of the fibers that found in the PMC, MMC, and CMC are the carbon and silicon carbide, right? Okay, the main difference is only the matrix. Okay, the main objective is to increase the toughness, strength, and stiffness of the material. High temperature, severe stresses application, automobile and aircraft gas turbine engine. Okay, fracture toughness value for ceramic materials are low because of the materials ceramics properties that have very tough but very brittle. So when we combine with the carbon or silicon carbide, let's say, so we are gonna have the better fracture toughness value, right? Okay, so the reinforced face that are commonly used are particulate fibers viscous of one ceramics, and for the matrix, for sure it must be come from the ceramics. Okay, so advantages of ceramics matrix composite CMC: very high application temperature range. Okay, compared to PMC and MMC, ceramic has very high application temperature range, more than 200,000 degrees C. So so because of that temperature range, it can provide advanced heat engine application. It also has low density and usually have very high elastic modulus value and chemical inertness. Okay, these advantages: brittleness, which make them easily susceptible to flaw. Still, even though it is a composite right now, but the brittleness of ceramic properties still there. So so the brittleness still is the advantages, the flaw of that CMC material. Okay, only employed high temperature reinforcement, high temperature for processing. So means when you have to process in very high temperature, so you need more money. It is very expensive. And lack uniformity in properties and have low thermal and mechanical shock resistance as well as low tensile strength. Okay, example of CMC is silicon carbide reinforced to using the aluminum oxide. Used as the cutting tool material, replacing the metallic carbide cutting tool. Cutting tool insert for machining hard metal alloy and so on. And for the CC composite, carbon and carbon composite, disc brake, hot pressing mold. So if you a fan of supercar or hypercar or maybe sport car, you will know that most of those cars are using the disc brake right now, using the ceramic composite. Okay, so if you want to know more about the disc brake from the ceramic disc brake, okay, you should find that in the Google, right? Okay, so this is the characteristic of composite material when you use the fiber as glass, and then you get that characteristic. Okay, so composite benefits, it increase toughness compared to the pure material. Okay, and it also increase modulus, increase creep resistance, and so on. So that's all for the composite. So let's say we revise back, we summarize back what we have learned in this video. The first thing is, what is the composite? Composite is the combination of two or more materials, right? Okay. It can be it has three main categories. What is called the particle and fiber reinforced, and also structural composite. Okay, and then from that we also have three another categories that we call it MMC, CMC, and PMC. That is based on the matrix material. If the MMC, it is the metal matrix. CMC is the ceramic matrix, and PMC is the polymer matrix. Okay, so that's all for our chapter 4, and then this is the exercises. So you should do the exercises, and the answer is here. You can check your own answer after you have done the exercise. And finally, this is our very last slide in our syllabus. So engineering materials, the main materials are metal, plastic, ceramics, and composite. So what we have learned in this video is we have learned about the composite. In the previous video we have learned about the ceramics, and the first video we learned about the metal. Okay, so that's all for today, and I hope you study hard and study smart for this chapter. We are going to have a quiz for the final quiz, and it covers all the chapter 4. Maybe next week I will announce that later in the WhatsApp group. And for the tutorial 2 8 and 9, if I'm not mistaken, I will put it in another video. Okay, so take care of yourself, jaga diri, and jangan lupa study. And Assalamualaikum, bye bye.